Welcome back. Here I am about to go through the TGC Level 2 Chem exam, Derived Grade exam 2024. This is the organic paper and this video is going to go through question 1. Okay, so we start with a pretty standard question here, and that is some naming and drawing. So I'm just going to put something underneath so my pencil doesn't go through. Okay, so first one here, we have longest carbon chain 3 carbons, so that's a prop. And the next thing I do is look for a functional group, and I see a triple bond, which is an ine. And that's all. So I just need to figure out, do I need to put a number in? And I don't, because it will be 1 or 1. So I can just call this propine. Second question, largest carbon chain, 1, 2, 3, 4. So that's a bute. And my functional group is an amine. So I can call it butane for all the single bonds. Amine, but I need to give it a number, butane 1 amine, or 1 amino butane. Either is good. Next one I need to draw is 2 bromopropanoic acid. So I'm going to start with the prop, and that is 3 carbons. And then the an for the single bonds, and the oic acid for my functional group, which I'm going to put here. And that now means that that's carbon 1. So 2 bromo comes off the second carbon, which is that one there. And then as this is an exam, I need to put all my hydrogens in and just double check that all my carbons have 4 bonds. 1, 2, 3, 4. This carbon, 1, 2, 3, 4. This carbon, 1, 2, 3, 4. And the last one, 3 methyl pentane 2-ol. So I've got pent, 1, 2, 3, 4, 5. I've got an, all single bonds. I've got 2-ol, so number 1, number 2. So I've chosen to put it from the right-hand side. So now everything has to be numbered from that side. So then my 3-methyl, so off carbon 3, which is this one here now, and a methyl, which is a 1 carbon, meth for 1 carbon, il for side chain. So I'm going to draw that like this. And then I'm just going to fill in the H's like so. And I do need to double check that I've got 4 bonds around each carbon. 3, 4. This one I've drawn like this, but I could have drawn it like this. And that's fine as well. It's the same thing. Okay, that's the first bit done. Right, next one. 1,2-dichloroethene, given the molecular formula, can form geometric isomers. So my first job is to draw the structural formula for the geometric isomers of 1,2-dichloroethene. So eth, 1, 2, and ene, a double bond, and I want 1,2-dichloro. So I'm going to put a Cl on 1, and I'm going to put a Cl on 2, and then these must have H's. And you'll notice here, just randomly, I have drawn the cis form. Over here, I need to therefore draw the trans form. So I'm going to put my Cl there, but this time an H there, and an H there, and I'm going to put my Cl over there, and that's my trans form. Remember, trans meaning across. All right. I now need to draw a constitutional or structural isomer of the same molecular formula that cannot form geometric isomers. So I have to still have a double bond. I've got enough atoms to not have a double bond. And the only way I can draw one that doesn't is to draw one like this. So that is 1,1-dichloroethene. There's only one possible answer there. Right, so I now need to elaborate on the features of that first molecule and this molecule here that determine whether each molecule can form geometric isomers or not. So I'm going to start with my standard opening. There are 2 requirements for cis-trans isomers to form. Make sure that you're using this plural here, because if you can form a cis, you can form a trans, so they always come in pairs. 1, a carbon-carbon double bond. Make sure you've said carbon-carbon double bond, which restricts rotation. So I'm linking that to Y. Whoops, that's bad spelling. Restricts rotation, fixing the atoms in place. And 2, each double bonded carbon, have to be clear here, must be attached to 2 different atoms or atom groups. Okay, so please try not, well, don't write functional groups here. H is not a functional group. It's not a correct statement. Okay, so this is what I'm always going to write with cis and trans isomers, and I now have to link this to the molecules in the question. So 1,2-dichloroethene has a non-rotational C to C double bond, and each double bonded carbon atom is bonded to 1 H atom and 1 Cl atom. So if I go down here, I can just go like this, different. Okay, so I can annotate my picture there, right? So this double bonded carbon has got 2 different things, and this double bonded carbon has also got 2 different atoms in this case. So cis-trans isomers form. However, despite 1,1-dichloroethene containing a carbon-carbon double bond, restricting rotation, the second requirement is not met, as each double bonded carbon has 2 of the same atom. One has 2 times H and the other 2 times Cl. So no cis-trans isomers form. And that's that one. Hopefully, it's a pretty standard question in level 2 chemistry, so hopefully everyone was pretty confident on that. Okay, and the last part of question 1 is about distinguishing, and we've got pairs. So we need to choose our own reagent in this question. They do not give it to us. So I need to choose something that can distinguish between these two. And my 2 options are bromine and permanganate. I'm going to choose bromine because I think it's easier. So what I'm going to see with bromine, Br2 aqueous is added to both. One will decolorize the orange, so I want a starting colour, Br2 quickly. The other will decolorize the orange slowly with UV light. Or you might say the first one decolorizes the orange quickly and the other one does not decolorize. Depends how long you would leave it. Okay, so that's our main thing. We do need to say which is which. The propene is the one that decolorizes. So, have I got reagents and conditions? Yes. So I've said aqueous bromine, and I've said UV light, and I've said the time for both. Observations, yes, I've got decolorizing orange and decolorizing orange slowly. Have I got the type of reaction? Not yet. The propene is the one that decolorizes the bromine as an addition reaction takes place. To form, and I'm actually just going to write the whole equation. It says I only need the structural formula, but if I start with my propene, which looks like this, then I can just make sure I'm getting the right product. Plus Br2. I'm going to break that double bond, copy everything else over because all I've done is broken the double bond. And in breaking the double bond, I have two sites to join, and so this is the orange thing here. It doesn't exist over here, so the orange thing is gone. So then I've done that one. All right. Okay, let's look at the next one. Propan 1-ol and 2-chloropropane. So I can either choose MnO4 minus and H plus, or Cr2O72 minus and H plus. So I'm just going to quickly nip through and see if there's another one in the question, and then I'll do the other one. No, there's not. Okay, so let's just pick dichromate for this one. Okay, and so in dichromate, I'm going to see an orange to green change, and if I had chosen permanganate, I would have seen a purple to colourless change. Okay, so if orange Cr2O72 minus / H plus is added to both, the alcohol will react and the colour will change to green, whereas the chloropropane will not react, so the orange stays orange. Okay, so what have I got here? Test reagent, yes. Conditions, yes. So I've got H plus. The only other thing I can put in here probably, if orange dichromate is added to both and warmed, because we want a bit of heat in there. And I've got the H plus, so that's good. Observations, I've got orange to green, and orange stays orange. Type of reaction, right. The reaction between propan 1-ol and Cr2O72 minus is oxidation, and the product is, and again I'm going to draw it, so I'm going to start with my propan 1-ol. Oops, don't forget that. And I'm going to put plus Cr2O72 minus / H plus. And I'm going to oxidize, which means adding oxygen in its simplest form. You're going to learn more about this after exams. And remember our golden rules of reactions. If you start with 3 carbons, you'll end with 3 carbons. And you will have the functional group on the same carbon, and you will make a product that you know how to name. So this is propanoic acid. And that's the end of question 1.